Hello and welcome to yet another installment of the Algebra 2 videos. And this is a very, very important section, section 4, and this is factoring trinomials when a is equal to 1. And so what we want to be able to determine today is if a trinomial with a leading coefficient of 1 and a positive constant is factorable, and if so, write it in factored form. We want to relate the factorization of a trinomial with a leading coefficient of 1 and a positive constant to a geometric model. So I'm going to show you guys a geometric model here real quick. And basically what this is called algebra tiles. And what you're able to do is I'm able to take this trinomial here, and by a trinomial I mean 3 terms, 1, 2, 3, and I can model this trinomial and its factors all at the same time, okay? And so we've kind of talked about factoring so far, but what we want to do is we want to show how to use a geometric model to factor something. And so what I'm showing you right here is this little animation that's actually found in on the Edgenuity video, where it shows x squared, okay, as the big block here, okay, plus 5x with the 5 individual blocks, and then 4 individual unit blocks, okay? And what we do, and what you'll have to do is you'll have all these different options of things to add or subtract to this, and then your job is to use this model to factor it, okay? And so what I've done is shown you that the first thing you want to do is put the x squared block in, okay, followed by 5 of the x's, okay, and then 4 of the individual ones. And then what you do is you look at this and you say, okay, if I took an x times an x, that gives me an x squared, okay? If I took an x times 1, gives me an x, so x times 1 gives me an x times 1 gives me an x times 1 gives me an x, and then same thing here. X times this one gives me an x, and then if we take each of these individual unit blocks and say, okay, 1 times 1 is 1, 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 then we get this, actually, this trinomial can be factored. Now, the thing that you have to understand is that this part right here, okay, this part right here is the rectangle. Needs to form a rectangle. So let me write forms a rectangle. Okay? And then what you end up getting is you get these factors, okay? And this is a factor, okay? And this right here is another factor, okay? And you'll be able to play around with this when you're doing your assignment and stuff like that. But the thing that needs to that I notice here is that when you have this, you end up getting this thing, okay, right here where you have this right here. This becomes the factor x plus 4. And this over here is the factor of x plus 1. So what we have here is I can take this trinomial, which is x squared plus 5x plus 4, and in previous ones we were factoring these out, but what we can do is we can factor this and say that this is equivalent to us saying that this is x plus 1 times x plus 4, okay? And so remember, and I'm going to show you how to verify that you've factored something right, but I'm going to show you that down here, okay? So what I want to do is I want to check to see if we're factoring using multiplication, and we often call this the FOIL method, where if I were to figure out if I factored this correctly to x plus 4 times x plus 1, what I would do is I would use the FOIL method, and that's going to be where I multiply the first terms together. Okay, so you get x times x. So the first terms, you get x times x, which gives you x squared. Okay, if you do the outside terms, okay, which is going to be x times 1, so x times 1, which just gives us an x, and then the inside, terms, okay, the 4 times x, okay, 4 times x, or x times 4, and this just gives us 4x. And then we have the last terms, okay? And the last terms are just going to be 4 times 1, okay, which is equal to 4, all right? And then what we do is we take all of these terms and we add them together. So add together. And so the only terms that we can combine are the x and the 4x. So we get this. We get this x squared plus 5x, x plus 4x gives me 5x, and then plus 4, which is the same thing that we had here, okay? And so because these are the same, all right, then we know that this is the correct, okay, if this is the same, then this is the correct factor, correct factorization, okay, and we'll call that the factorization. Okay, and remember, guys, that when you factor something, factoring is just the opposite. So factoring, okay, is the opposite of foiling. And that's it, okay? And foiling really is just using the distributive property, but foiling is a way for us to remember, okay? And so that's, what I've got. So I just wanted to show you, you will be asked to do the geometric model to show that, but we're going to go through and show you a number of different ways to go about this and figure out how to factor it without having to use this method. Okay, so the next method that we have is called the X method. And what I often like to do, and this is actually a pretty good method because I'll be using this method in other sections. But so the X method, and it's also can be considered the box method. But let's go through this. And so it gives us some steps on how to solve this. And it says write the product of AC at the top of the X. That goes here. So you take the coefficient A, the coefficient C, write the B term, the middle term and that's this number here, over here. And then we want to write the two numbers that have the product of AC and the sum of B on the sides of the X, okay? And then we replace the X term in the trinomial with the two X terms, and then you can use double grouping to factor the 4 terms. And I'll show you guys kind of 2 different methods on how to do this, but if you had, and let's just jump into the example down here. Okay, so factor. So I've got this example here where it's x squared plus 8x plus 12. Okay, and I'm going to draw my x. Okay, and the first thing I'm going to do is identify what my a value is. A is equal to 1. Okay, here where there's nothing, and then my b value is equal to 8. And then my C value is equal to 12, okay? So if I take my values for A and C and multiply them, I'm just going to get 12, okay? 1 times 12 is 12, okay? And then I'm going to get, I want to put my B value 8 down here, okay? So now what I want to figure out are 2 numbers. So the question is, okay, 2 numbers that multiply to 12 but add to 8, okay, but add to 8, all right? And those numbers, you can kind of just think about it for a while, but it's going to end up being the numbers 2 and 6, okay? So what I would do then, okay, is I would take my trinomial, which is x squared plus 8x plus 12. And what I do is I can do this thing called splitting the middle term, okay? And I'm going to take 8x and rewrite it as the sum of 2 and 6. And so what I'll do here is I'll say that this is just going to give me x squared plus 2x, okay, plus 6x, and then add 12 to that. So I'm really just taking 8x and splitting it up into those 2 terms. Now what I can do is I can just then factor by grouping, which is what we did in the last section. So I'm going to take this and I'm going to group it. And in this group here, in this quantity here, x squared plus 2x, I can factor out a common x. And I'm left with x plus 2. Okay? So if you don't know what I'm doing, you may want to go back and rewatch the videos from the last section and go from that. And then, okay, out of this group, I can factor out a common value of 6. So I have a plus 6, and that leaves me with an x plus 2 factor. Okay, now what I can do is I can factor out a common x plus 2 factor, and I'm going to end up getting, if I factor out x plus 2, then I'm just left with x plus 6, okay? So what I have here is this is in factored form, all right? And this is equivalent to me writing x squared plus 8x plus 12, okay? Same thing, all right? It's just that this is in factored form. I could remultiply this out and check to see if I get this as a result, but it's just what it is. Now, here's the thing. I like this box method because I'm going to use this later on. Now, you may have been kind of familiar with this already, but the thing that's going to be easy about this, and this is kind of just a special case. So, and I want you to write this down. Okay, so if the leading coefficient is a, or is 1, okay, is a equals 1, okay, then using this method, okay, you just have to answer the question, what two numbers add to 8 and multiply to 12, and those are the two numbers that are going to be the two numbers of your factor, x plus 2 and x plus 6, okay? So if the leading coefficient's a equals 1, then the grouping is not really necessary. Grouping isn't necessary. Now what I will do is when a is equal to 1, okay, it's not necessary, okay? But when the grouping is not, when a is not equal to 1, when your leading coefficient a is not equal to 1, then the grouping and using the x method here is completely necessary. Okay, and it's kind of hard to not do it, all right? So let's just go ahead and let's look at another example here. And this is going to be, let's just go ahead and factor x squared minus 13x plus 40. Okay, so first things first, I'm going to say, okay, what's my a value? My a value is 1. So I don't have to do the grouping, okay? So I'm going to write over here, since a is equal to 1, that means that we're going to, no grouping, okay? But my b value is equal to negative 13, and my c value is equal to 40. So what I'm going to do is I'm going to make my x, okay? If I take the a times c, that's 1 times 40, which is just going to give me 40, okay? And then put my middle term here as negative 13. All right, so now the question is, all right, well, what two numbers, okay, multiply to 40, but add to negative 13? Okay, and so the numbers that I can think of, and you're going to have to think positive and negative numbers here because they have to add to negative 13, okay, but they have to multiply to 40, then these two numbers probably need to be negative. A negative times a negative gives us a positive, but if you add two negatives together, you get another negative. So these numbers are going to be negative 8 and negative 5, okay, and you can kind of play around with this, okay, write these numbers down and say, okay, negative 8 times negative 5, that's positive 40. Negative 8 plus negative 5, does that give me negative 13? So what I do now is I just then, because a is equal to 1, I don't have to group this. What I can do, I don't have to split the middle term. What I can just do is, write out my binomial and then just set that equal to the factors. And all the factors are going to be is just going to be x minus 8 times x minus 5. And that's it. Okay, we're done. So it's kind of easy, all right? It's not too bad, all right? So, that's kind of all I've got, all right, for those. It's pretty easy. I like the box method. I'm pretty good with the box method, the X method. But let's look at this next thing called the box method, okay? And so what I want to do is, consider the trinomial here and sit here and go, okay, if I do the box method, what I do, my first step is I'm going to draw my box, okay? And the box is going to look like this, okay? And so what I get is I can do this, and I can say, all right, well, I'm going to put my x squared term, I'm going to put that here, x squared, put that there, and I'm going to put my last term, my c term, 18 here, okay? And then I just kind of have to think, and this is kind of like the geometric model, but what I'll do is I'll say, okay, if I take an x, like you have to think to yourself, what two numbers multiply to x squared, okay? And that's just going to give me x and x. So I'm going to put an x here and an x here. So I say this x times this x gives me x squared, okay? Now you have to sit around and you have to go, okay, now what two numbers multiply to 18? Okay, and you can think of like 9 and 2, but these two numbers have to also add to -9, okay? And so what I'm going to do is this. I'm going to say, all right, well, this is going to be, negative, let me do -3 and -6, okay? So, and the reason why I do that is because I take -3 and multiply it by x, and that's going to give me -3x, okay? And then I take x times -6, and that's going to give me -6x. Now, if I add these two numbers together, okay, then that's going to give me -9x. And the beautiful part about this is that I have my factors up here. Okay, so then what I would say is I've got x squared minus 9x plus 18. If I factor that out, then I get x minus 3 times x minus 6. And this is factored, okay? And that's all I need to do. So those are three different methods, okay? And it kind of just depends on what you guys want to do. It doesn't really matter to me so much, but, whatever makes you comfortable, okay? So let's just do this. Okay, I'm going to do this a couple different ways. I'm going to do this using the box method, and I'm going to do it using the x method, okay? And we'll end up getting the same thing. So first, let me do the box method, okay? And so if I do the box method, I'm just going to draw a box. All right, I'm going to put my first term, x squared, in here, my last term here, and then I'm going to ask myself, okay, what two numbers multiply to x squared, and that's just going to give me x times x. Okay, so those go there. And then what two numbers multiply to 9? But at the same time, they have to add to -6. So if I think, okay, well, what if I did -3 and -3? Okay, then I take -3 times x, that gives me -3x. If I take -3 times x, that's going to give me -3x. And if I add those two together, that's going to give me -6x. So, and that's all I care about, because then I have factored my trinomial, okay? And so then I just know that x squared minus 6x plus 9 factors to x minus 3 and x minus 3, okay? And then actually we can say that that's x minus 3 quantity squared, okay? I've got two of them. And so that's the idea, and hopefully you guys have seen this before. And it's really kind of simple. Whenever you've got a leading coefficient of 1, you don't necessarily have to do this. You have to just ask yourself, okay, what two numbers multiply to positive 9 but also add to -6? -3 and 3, and boom, you factored it, okay? So, that's all I've got for this section. It's only a couple of examples, but you must practice this, okay? You have to practice this. I'm not going to go ahead and do the X method on that. I'll wait till the next video to explore that a little bit more. All right, talk to you later. See ya. Bye.